Right, so I think we can start. So I will position myself here in front of the camera. So when I was working for the last couple of months on software development, I discovered that you are often given a recipe on how to get things running on different platforms, but it is just a recipe. And just as much as a cook needs to know what spices to put on some condiments, you also need to know what else do you need to make your deployment secure. So my name is Natalia Nowakowska. I'm a software engineer at Canonical working in identity team, and welcome to my talk. So why would you even need this, and why did you join this talk? So it's talking to various people, various audience. So first of all, if you're an admin, you probably want to know how to get things deployed correctly and securely. If you're a developer, you probably want to know how to build secure software. If you're a writer, you probably want to write a good documentation for the end user. If you're a user, you want to know what awaits you and how to mitigate some risks. And if you're a hacker, I hope you don't use any of those for malicious purposes. So the outline of the presentation, first we're going to go through some security misconceptions around Kubernetes. Then I'm going to show a very quick example on privilege escalation, and I'm also going to show you how to quickly get running with MITRE and on multipass. And then I'm going to shortly talk about how to protect from this. So there is a very common misconception that if you are running workloads on Kubernetes, you have containerized applications, so everything is isolated. That's not true, which we're going to see during this presentation. Also, there are many insecure defaults or some configuration that are default, but you need to change them in order to make your deployment safe. And also, you are often given excessive permissions. So just look at the back model. And as an admin or whoever else that you are using this as, you need to know how to use those powerful tools. And it's up to you how to secure it. So I wanted to show you actually that Canonical is more than just Ubuntu, and I wanted to show you how to get things running on multipass, how to launch a multipass instance, and the micro case that you can use later for the development. This is pre-recorded, and I'm very sorry for the quality, but Google made it quite bad. But hopefully you will be able to see something. So first, we are launching any instance that you want. You can also launch instance that you don't have on your laptop. You can use an older version of Ubuntu or a later one. You can assign some resources. It's up to you how much you put. It should take up to a couple of minutes. Depends how much resources you assign. Also, you can create your own images so that you can always get Microk8s run by default, Juju, and some other stuff that you're using at Canonical. You can just list the instances that you have, just shell into them, and install whichever software you want, which in this case I'm going to do with Microk8s. And it's basically taking a couple of minutes to get things done, and you can set up this environment for your own tests. Okay. So in the next video, I'm going to show you the basic setup. So we assume that we have a developer user that should have basic access, whichever developer needs, so like to schedule pods, to manage deployments, to view node information, and that's what we're going to assign. We're going to first see what permissions the user has. So we will switch to the context of the dev user so that we can be sure that we are not running those commands from admin perspective. And here we are able to see that this user cannot even get pods in the open project namespace that was supposed to belong to the developer user. Same for deployments in the same namespace. And here we're going to assign some permissions. So for this, we need to change the context to Microk8s to the admin. Here we can see we can now view the pods, but there are none. we're going to create them later on. And here I'm creating a cluster role. I'm creating roles for reading nodes, reading pods, and for managing deployments, so any action that needs to be done with deployments. And now we're going to also test the model. So we assigned through the role bindings the permissions to the user. And again, I'm switching the context to the dev. And the dev should now be able to create deployments in his namespace. Same for scheduling pods, but should not be able to deploy anything in kube system namespace, which is basically the idea behind the back. And yeah, you were able to see some of the permissions or some of things that the user is not allowed to do. Okay. So what the user actually has access to is to, for example, view node information, schedule pods, or manage deployments in any way, create, delete, update, whatever. But outside of his scope are viewing secrets, creating roles so that the user cannot assign himself any new permissions. So what is the plan for this specific case? We're going to try to schedule a pod on a master node, which normally is not possible if you secure your cluster well, but in that case, we will see that it is enabled. So I will force the scheduler to get it on the master node by using labels. And within that pod, I'm going to have a container with BusyBox, so the basic utils for Linux. And within that container, I'm going to run a command that will go to the location of certificates. And those certificates will be then visible in the logs of the pod. And since the user, as we can remember, has access to view the logs, he will also be able to see the contents, so the private key and the certificate. Okay, so we're going to basically just run the deployment. It's a very short talk, so I'm not showing the deployment, but it's running the command to get the certificates location. It's not ready yet, but it will be in place soon. And then once it's ready, we're going to see that we can see the certificates. So we can basically just copy paste the certificate and the key. And then we can use it to create a new user, to request a new user, to create a certificate signing request, and then to sign it. So I created a stolen directory where I got my certificate and key. And I'm here creating a new user, an imposter user, and I will sign the certificate signing request with the certificate and the private key that I got in the first step. And I'm also going to set a new context for that user and use that context to then see whether I can have some more permissions that I initially had. So now you will be able to see that I can, for example, delete namespaces, even the namespace that I was working on initially, and I can also create roles, so I can escape from that container. And within that, I can create any role, assign anything I want to myself. So now we're going to the part how to protect from it. So first of all, there is a lot of configuration that if it was in place, I wouldn't be able to perform that kind of attack. So for example, first of all, we should ensure that we are correctly using the airbag model. So we need to assign all of the roles, the permissions correctly. We should not give any excessive permissions. And also remember that the permissions are purely additive. There are no denials by default, but there are some people who can misuse it. Then we should use app armor. So for example, to protect the sensitive information, like sensitive certification directory. So in that case, we wouldn't be able to even get to that directory. And also we wouldn't be able to schedule any workloads on the master node. What else? So we should always check the Docker images that we're using. So we should always do at least Docker inspect to see what user the container will run with. If it's with root, which is often the case, we should probably change that. We can also use Docker scan. And also we could use admission controllers, which is an additional substrate. So once the user is authenticated and the request is authorized, admission controller will intercept the request that is coming from the user and will decide whether that needs to be mutated or whether it will be validated. Sometimes it needs to be changed first. And with the usage of admission controllers, you will ensure that the user doesn't do stuff that is not supposed to, that was not caught by the bug. So, for example, we could use the code node selector. Also remember that you can use your own admission controllers. You can write your custom ones, so that allows you to secure your cluster very well. And one more thing, avoid to run privileged containers. This is general good practice. And I think I've run through most of the ways how to protect your cluster. Also, this image is not random, because as you can see, there's always a room for improvement. So remember that the Kubernetes world is changing very quickly, and you always need to be aligned with the latest security recommendations, and you need to know what new is in place, so you need to follow the recent security issues and how to prevent from them. All right, so I hope that with this talk you will now know that you need to secure your clusters, even if you're running some application, some software that is supposed to be secure by default. You should always keep in mind some stuff, depending also if you're using Microk8s, if you're using Minikube or any other mini deployment of Kubernetes, or you're using a full Kubernetes. So remember to try out also Microk8s so that you can quickly see to try your back model or just test your applications. So that was it from my side. Thank you.